Hi, today we'll discuss Introduction to Java Collections and Stacks. So the collection terminology, we'll discuss the Collections API, the abstract nature of collections, stacks, conceptually used to solve problems, and implementation using arrays. So collections. A collection is an object that holds and organizes other objects. It provides operations for accessing and managing its elements. Many standard collections have been defined over time. Some collections are linear and others are nonlinear in nature. So here's a linear collection and here's a nonlinear collection. So this could be like a stack and this could be like a tree. We'll go over those later. So an abstraction. An abstraction hides details to make a concept easier to manage. All objects are abstractions in that they provide well-defined operations. The interface. They hide, encapsulate the object data and the implementation of the operations. An object is a great mechanism for implementing a collection. Abstract data types. A data type is a group of values and operations, and the operations define on those values. An abstract data type, ADT, is a data type that isn't predefined in the programming language. A data structure is a set of programming constructs and techniques used to implement a collection. The distinctions between the terms ADT, data structure, and collection is sometimes blurred in casual use. Collection abstraction. A class that uses a collection interacts with it through a particular interface. So here's the class that uses a collection. Here's the interface, and here's the class that implements the collection. The Java Collections API. As you know, the various classes provided with Java are referred to as the Java API, Application Programmer Interface. The subset of those classes that support collections is called the Java Collections API. As we explore a particular collection, we will also examine any support provided in the Collections API for that collection. Stacks. A stack is a classic collection used to solve many types of problems. A stack is a linear collection whose elements are added in a last in, first out manner, LIFO. That is, the last element to be put on a stack is the first one to be removed. Think of a stack as a stack of books where you can add and remove from the top, but you can't reach into the middle. So here's a diagram of a stack, and it's the conceptual view. So here's the top of the stack, and then you push an element onto the stack, and then you pop it off. So you add an element with a push, and then you pop it off, and that removes it, and it's all from the same index. So the top, you're always adding to the top, and you're pushing the exact same one, and you're popping it. But in your IDE, should be depicted horizontally, starting from left, index 0, and going to right, to infinity. Stack operations. Some collections use particular terms for their operations. These are the classic stack operations. So push adds an element to the top of the stack. Pop removes an element from the top of the stack. Peek examines the element at the top of the stack. Is empty determines if the stack is empty. Size determines the number of elements in the stack. I think in the stack class, in java.util.stack, it might just be called empty. So a lot of the collections share similar methods. So it's either is empty or empty, and I think for stack it's called empty. But for array list it might be just empty. And array too. Object-oriented concepts. Several object-oriented concepts, new and old, will be brought to bear as we explore collections. We'll rely on type compatibility rules, interfaces, inheritance, and polymorphism. We also rely on a programming mechanism introduced in Java 5, generics, which are particularly appropriate for implementing collections. Generics. Suppose we define a stack that holds object reference, which would allow it to hold any object. But then we lose control over which types of elements are added to the stack, and we'd have to cast elements to their proper type when removed. A better solution is to define a class that is based on a generic type. The type is referred to generically in the class, and the specific type is specified only when an object of that class is created. The generic type placeholder is specified in angle brackets in the class header. Example, class box, and then in angular brackets t, and it's defined. This is the method description or class, just whatever. Any identifier can be used, but T for type or E for element have become standard practice. Then when a box is needed, it is instantiated with a specific class instead of T, so specific object. So here when you instantiate it in main, it's box, angular bracket, widget, in angular brackets, and then we called it box1 equals new box, and then widget. So it's the same as the array list. You're basically just doing the same thing, and you have options to add parameters. Now box1 can only hold widget objects. The compiler will issue errors if we try to add a non-widget to the box, and when an object is removed from the box, it is assumed to be a widget. You can instantiate a box2 to hold strings if you want, or integers, or any object wrapper class. Box string box2 equals new box string. Parameters if you take them in the constructor or using the same class. Another object can be instantiated. So here you could either call box2 and set it to string objects, or you could call box2 to add it to gadget objects. So another example is box and then of type gadget. Box2 equals new box of type gadget with no parameters. The box2 object can only hold gadget objects. Generics provide better type management control at compile time and simplify the use of collection classes. Postfix expressions. Let's see how a stack can be used to help us solve problems of evaluating postfix expressions. A postfix expression is written with the operator following the two operands instead of between them. So 15, 8, and minus is equivalent to the traditional infix expression 15 minus 8. Postfix expression. Postfix expressions eliminate, this should be here. Postfix expressions eliminate the need for parentheses to specify the order of operations. The index expression 3 times 4 minus in brackets 2 plus 5 times 4 divided by 2 is equivalent to the postfix expression 4 times 2 plus 2, 3, so 3, 4 times 2, 5 plus minus, this should be what's, I think it's 4 times 2 divided. Evaluating a postfix expression. We'll use a stack as follows to evaluate a postfix expression. Scan the expression left to right. When the operand is encountered, push it onto the stack. When an operator is encountered, pop the top two elements on the stack, perform the operation, and push the result onto the stack. When the expression is exhausted, the value of the stack is the final result. Here's how the stack changes as the following expression is evaluated. So this is what we did in one of the example codes. So the stack, evaluating a postfix expression using a stack. So this is just a diagram explaining the top. Stacks in the Java API. The postfix example uses the Java.util.stack class, which has been part of the Java Collections API since Java 1.0. It implements the classic operations without any separate interfaces defined. As we'll see, there is not a lot of consistency regarding how collections are implemented in the Java API, and we'll explore their relative benefits as appropriate. So this is a UML diagram of the example that we did, except main is just called main, it's not called postfix tester. So Javadoc, the documentation style used in the postfix example is called Javadoc. Javadoc comments are written in a format that allows a tool to parse the comments and extract key information. A Javadoc tool is used to create online documentation in HTML about a set of classes. The Java API documentation is generated in this way. The Javadoc comments begin with slash or backslash, asterisk, and end with asterisk backslash. Specific Javadoc tags, which begin with a @ are used to identify particular information. Examples of Javadoc tags: @author, @version, @param, @return. So here's a Javadoc for a method. So we start with a \***. We retrieve this is just method description. Then you just do the parameter with @param. So it's @param cat. Should match the parameter here. And then @return should match whatever you're returning. And then you just close the Javadoc with the asterisk and the backslash. Exceptions. When should exceptions be thrown from a collection class? Only when a problem is specific to the concept of the collection, not its implementation or its use. There is no need for the user of a collection to worry about it getting full, so we'll take care of any such limitations internally. But a stack should throw an exception if the user attempts to pop an empty stack or peek at an empty stack. A stack interface. Although the API version of a stack did not rely on a formal interface, we will define one for our own version. To distinguish them, our collection interface names will have an ADT abstract data type attached. Furthermore, our collection classes and interfaces will be defined as part of a package called JSJF. So public interface stack ADT in angular brackets T. Actually, I probably won't be doing this package called JSJF. You could just ignore that. A stack interface. So here's the interface. In UML, you just depict it with the interface at the top. And then here's the title, and then here's the methods, the parameter, and what it returns. And then it's of generic type T, so that goes at the top too. So implementing a stack with an array. So we also did this in the example code, so let's just talk about it. So let's now explore our own implementation of a stack using an array as the underlying structure in which we'll store the stack elements. We'll have to take into account the possibility that the array could become full, and remember that an array of objects really references to those objects. Insert an array. Sorry, that's my note, so that's fine. Managing capacity. The number of cells in an array is called its capacity. It's not possible to change the capacity of an array in Java once it has been created. Therefore, to expand the capacity of the stack, we'll create a new larger array and copy over the elements. This will happen infrequently, and the user of the stack need not to worry about it happening. By convention, collection class names indicate the underlying structure, so ours will be called array stack. Java.util.stack is an exception to this convention. Our solution will keep the bottom of the stack fixed at index 0 of the array. A separate integer called top will indicate where the top of the stack is, as well as how many elements are in the stack currently, so the length, and it also indicates where the top of the stack is. Creating an array of a generic type. So you can't instantiate an array of a generic type directly. So in our program, instead, we create an array of object references and cast it to the generic type. So example, stack equals, and then we did t-array, and then, so we did stack equals, and then t-array, and then we said new object initial capacity as the array index. So defining an exception. An empty collection exception is thrown when a pop or peek is attempted when the stack is empty. That's why we created that class in the example code. So the empty collection exception is defined to extend runtime exception. By passing a string into its constructor, this exception can be used to other collections as well. Alright, thanks.